Hello everyone. Uh, as you know that I am doing the material science previous year questions, and this is directly from the exams like GATE, Engineering Services and Civil Services. I have already completed till L16, almost 16 lectures. This is the 17th one. Okay, so I think maybe 7 to 8 lectures I will take more for completing most of the problem from the material science. Okay, so this is the collection of last uh, 20 to 25 year questions. Okay, so anyway, we'll see that today's lecture, and we'll deal some 12 questions in this video. Okay, so this is about myself. Okay, so the question number 11, I think 10th till 10th already I've completed based on the whatever topic I'm dealing now. So the question number 11 says, consider the following quenching media. Okay, oil, water, water plus NaOH, brine. So they are asking the correct sequence of these media in order to increasing hardness of steel undergoing is treatment, undergoing heat treatment. Okay, so they are asking for the correct sequence. Okay, so these are the options. We'll see that. See, actually the first will be the oil. Okay, second will be the water, third will be the water plus NaOH and brine. So whatever sequence is given, that is the answer. Okay, so no need to change anything. So the answer will be C. Now we'll see the next question. So next question is like match list question. So there is effect of cooling medium. So these two are given. So martensite, very fine perlite, coarse perlite. Okay, so to whom we have to match it? Water quenched, air cooled, furnace cooled, oil quenched. Okay, so martensite, you know that. Okay, martensite means you heat in the furnace and just directly dip in oil, water, whatever it is. Okay, so that is actually will give the martensite is the hardest form of any steel. So we have to match with that. So it will be okay. So water quench, oil quench. Okay, so we'll see that. Okay, so martensite, like we have to it will be oil or water quench. Like see, immediately we have to cool it. So the best is water. So it is. See, actually, quenching is not like only in water. It can be in oil or in some other fluid as well. But when we are talking about martensite, okay, so martensite, in martensite we have to dip into the water. Okay, so it will be the martensite will match with the first one, water quench. Second is the very fine perlite. So this will be actually oil quenched. And then fine perlite, so this will be air cooled, and the rest is coarse perlite means furnace cooled. Okay, so we have to heat in the furnace and we have to cool in the furnace. Okay, so that is also known as annealing. Okay, so if you want to get coarse perlite, so we have to actually do the annealing, something like that. Okay, so its answer will be A. So here instead of talking normalizing, annealing, they are matching with the what kind of grains you are going to form in different type of coolings. Okay, so this question based on that kind of property. Next question we'll see that. Okay, tampering. So tampering is a process of annealing. Okay, martensite at low temperature, martensite at higher temperature, benite at low temperature, benite at high temperature. So it is actually martensite is will give martensite at low temperature. Okay, so here, see, here I'm not going to tell about like how we have to get, what is the tampering, how we have to do that. When I will teach, material science, there I will, explain uh, what is tampering. Okay, so here, because if I will start explaining, each and everything, then this previous year question will take a lot of time, and my target is to, finish in 10 to 12 minutes or maximum 15 minutes. So you should get an idea what kind of question is coming in the exam. Okay. So if you're doing the tampering, you'll get martensite at low temperature. Next, Oz tampering. Okay, Oz tampering is employed to obtain 100% martensite structure, 100% benite structure, 50% martensite and 50% benite structure, 100% pearlite structure. Okay, this will actually give the B 100% benite structure. Okay, again here also I'm telling what is Oz tampering. So when I will teach material science, then I will explain these things in a very elaborative way. Next, considering the following pairs, so here is heat treatment, effect of medium carbon steel. Okay, so normalizing, full annealing, mar tampering, sporadizing. Okay, so grain refinement, uniform grain structure, decreased ductility, maximum softness. So they are asking which one is correctly matched. Okay, so we'll see. So here actually, normalizing is matching with the grain refinement. This is correct. Full annealing will give the uniform grain structure. Okay, but this is mar tampering. No, so this will not give ductility. Decreased ductility, and this also is wrong. So the answer is A. Next question. Tampering of quenched martensitic steel is necessary to improve the hardness of steel, hardness of the metal. Okay, anyway, surface structure or the metal, corrosion resistance of the metal, ductility of the metal. Corrosion resistance will not be there. Okay. So we'll see that. Its answer is actually D. Okay, so tampering of quenched martensitic steel is necessary to improve the ductility of the metal. Is not or is of the metal. Next question. Machine tool guide ways are usually hardened by vacuum hardening, mar tampering, induction hardening, flame hardening. This is actually mar tampering. So this is actually property of mar tampering. Question again, it's a match list. Heat treatment, effect of the properties. So annealing, nitriding, mar tampering, normalizing. Okay, so what kind of structure we have to get? Refined grain structure, improve the hardness of the whole mass, increase surface hardness, improve ductility. So we have to match with these. Okay, see, so annealing will improve the ductility. Okay, what is annealing? We have to cool in the furnace itself. Nitriding, it will improve the surface hardness. Okay, mar tampering, it will improve the hardness of the whole mass. Okay, and normalizing, the grain refinement. See, actually, if you don't know all, so if you see the annealing and normalizing, these we can easily know that. So if you from these two, you can eliminate two options and you can get the answer. Understood? So sometime what happen in the match list, if you don't know all four, so whatever you are knowing, so based on that, eliminate the answer. Most of time you will get the answer, and even if you're not getting the answer, go for the next one, and with some clue you can solve that question. So its answer is A. Next, this GATE question, GATE 2004. Let's read that. From the list given below, choose the most appropriate set of the heat treatment process and the corresponding process characteristics. Okay, so process characteristics we have to match with this. Tampering, Aus tampering, Mar tampering. Okay, so austenite to convert into benite, austenite to convert into martensite, cementite to convert into globular structure. Both hardness and brittleness are reduced. Carbon is absorbed into the metal. We'll see tampering. Okay, so the tampering is nothing but it's both hardness and brittleness are reduced. Okay, Aus tampering is nothing but austenite is converted into benite. Okay, and Mart tampering is nothing but austenite is converted into martensite. Its answer is C. Okay, so these three is third and fifth is not matching with anything. Next question. Hardness of steel greatly improves with annealing, cyaniding, normalizing, tampering. Okay, so I think you can answer this question. We have seen a lot more question of this kind of. So this is actually D, tampering. Okay, next question. On completion of heat treatment, the resulting structure will have retained austenite if rate of cooling is greater than the critical cooling rate, rate of cooling is less than the critical cooling rate, martensite formation starting temperature is above the room temperature, martensite formation finished temperature is below the room temperature. Okay, so on the completion of heat treatment, the resulting structure will be retained austenite. Okay, so that's about retained austenite. So what happened here? Martensite formation finished temperature below the room temperature. This is the answer for this question. Okay, let's see the next question. Okay, I think this is the end of this lecture. Okay, so okay, anyway, next video I will come up with some more problem. Okay, we are actually moving towards to finish this material science question. I think I will take 4 to 5 or maybe 6 lectures more to finish this lecture series of previous year question of material science. Okay, I hope you like that. Thank you for watching. Bye bye.